before. Probably some people got tired of me repeating this extra credit mantra, but they can always do this. If you want, you can always do this. So anyways, exercise 8 was for the quiz that talked about 3 choices for the size of the pizza, and at the same time 4 choices for the crust. So and means times, so we got times 4, and 6 choices of toppings. So the key idea is that we have and, so that means times, and that's how we actually do those exercises. So let us see what the answer is going to be when I multiply these numbers, such as a 12 by 6. It looks like it's 72 possible choices for the pizza. I say, Alex, how come there's 72? I thought there's just like only 6 choices of toppings. Well, they say how many one topping pizza is ordered. So when you start ordering pizza, they ask you, first of all, what size do you want? Do you want a small or you want a large, right? So that's different. So that's important to realize that even though you like one topping, but there's a size of the pizza. So it looks like there are 3 sizes in here. So there's a small, medium, and a large, right? Now, the second choice, they ask about the crust. It looks like there are 4 choices for the crust. So if you selected the small one, it could be thin, thick, crispy, or regular. With medium, you have 4 choices. Same 4 choices, but it's a different size. And with a large, exact same choices. So you already have 3 that come with 4 possibilities each. So here's 4, here's 4, here's 4. That's why you multiply 3 by 4 and you get 12. And then finally, there are various toppings, and they say there are 6 toppings. So with this one, there are 6. With that one, there are 6. You see, with that one, there are 6. With that one, there are 6. So you have 6 with each of these, with each of those, and with each of those. So notice that you have 6 taken 12 times. And that's exactly what happened. That's why we multiply. So you don't want to try to produce this tree-like diagram. I'm just trying to kind of clarify what is really going on in here. So you have 6 that appears with each of those, and looks like there's 6 times 12 that you actually count. And when you multiply, you get 72. So just multiply. Don't look at it. Multiply. So I was asked to do problem number 16. So let's check out what is going on here. That talks about a multiple choice test with 5 questions. Okay, so whenever we have a test, we can always see there's some kind of little picture to get it better. And each of the equation has 3 answer choices. So 3 choices here, 3 choices here, 3 choices here, here, and here. 3 possibilities. Okay, so how many ways can you answer this? So it's 3 and 3 and 3 and 3. So it looks like you have to multiply, right? 3 with itself 5 times, or get something like 3 to the power of 5. And we'll multiply it, looks like 243. So multiplication rule. Please notice this is a little bit different because you not having the pizza-like story like a tree diagram. You just have 3 choices for the answer for each of this multiple choice test. So looks like that's how it works. So yes, problems are not all identical, but the key idea of multiplying things is going throughout entire section. So that's what we need to get used to, I guess, a little by little. Another question was for exercise number 11. So let's check out what's going on with this one. That says shoppers in a shopping mall categorized or male or female. Okay, so an exercise number 11. We have two genders here, and they are over 30 or 30 and under. So there are two possibilities, male, female, and then there is a over and under 30. So you can say what? Over 30 or under. And here's again, over 30 or under. Somehow I want to describe this. And cash or credit shoppers. So here we have cash or credit, or R. Here's cash or credit. Here's cash or credit. Here's cash or credit. So it looks like we have two selections for genders, two selections for age, and two selections for payment. So please notice that there are a total of two that comes with each of the previous four possibilities. So I go 4 times 2, which is going to be 8, right? So it looks like total, a little bit more carefully, is 8. And once again, we just do nothing but multiply all of those possibilities. So the total number of categories is 8. So what are the categories? Well, for example, if you go along the first branch, the category will be male over 30 uses credit. The other possibility, male over 30 uses cash, and so forth. So you can list all of those, and the total will be 8. And that's what they asking us about. What be the total? So they don't want to list all of them because it takes a while usually. So looks like all we do is we multiply here. Well, what else is in this chapter? Well, let's check it out. Let's look at the next section that will continue with more of this multiplication ideas. And I'd like you to first notice one very interesting story with a special little symbol. So for example, if you try to multiply numbers 1, so 4, 3, 2, and 1, which is equal to 24. It turns out that you could write it a little bit differently. You can write it as 4 with this exclamation sign. So it doesn't mean that you need to scream out loud, 4. No, that's not. It's called 4 factorial. 4 factorial. And it turns out if you go to the calculator, then there is a special symbol factorial here. So if I select 4 and I go to functions, you see, there's main menu, A, B, C, and there's a functions. Then factorial appears in the lowest row and the third position from the left, factorial. You see that exclamation sign? And it's actually 24, just like we had calculated, I would say, intuitively. So it is still same 24. Well, that's what they're actually talking about in this example. So they're talking about utilizing this factorial symbol to count things. And notice that they actually have these various factorials, such as a 7 factorial and so forth, 9 factorial, 10 factorial. And turns out it's not hard to calculate them. So to get 10 factorial, you actually have to multiply numbers 10 by 9 by 8 by, I would say, dot, 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 all the way to number 1, right? And of course, to start multiplying these in your head would be quite a challenge if you try. And that's why people just put this in a calculator. So I go back to main menu, put 10, go to functions, and use this symbol factorial, and I get a big number, 3,628,800. So this is indeed a big, big number. And of course, you can double check this with the little diagram they have here on the left side. So if you can consider this diagram with 10 factorial that I just circled on the left, you will see indeed it's 3 something million. You will also see that the factorials, they increase tremendously fast. Please notice that if you go not 10, but just 20 factorial, the number will deal with what? Million, billion, trillion, quadrillion, octillion, sextillion, 2 sextillion, 432 octillion, 902 trillion, and then you have some more. So it's really the number that very, very big. In fact, these factorials increase so fast that if you try to find something like 100 factorial, for example, look at what's going to happen. Just 100, and if you put factorial to the end, it's 157th power of 10. The decimal point needs to be shifted 157 places, so there will be so many zeros. So if you try 200 factorial, the calculator is not going to handle it. Yes, calculator has its limitations. It cannot calculate very big numbers. You say, Alex, what about 300 factorial? Well, if it cannot handle 200 factorial, it wouldn't be able to handle any bigger factorials either. Interesting, right? So those are very, very big numbers, those factorials. So we're dealing only with the lower side of the story, like 10 factorial, 5 factorial, but not 300-400 factorial. No, they're increasing tremendously fast. Of course, there are ways to handle those big numbers. People purchase special so-called numerical processors if they need to work with those big numbers, but not too many people need those big numbers. Maybe just a Bill Gates and a company, but not really very often they should need it. So anyways, let us go back to this little exercises and see what else this section is talking about. They give us quite an amazing definition. It's called definition. And they say that 0 factorial is 1. I know it is amazing, but so how come 0 factorial is equal to 1? Well, it's definition. So we don't really want to start to think hard about it because it's definition. So that's important to realize. So anyways, let me clean this a little bit and see what else is here. Now it's all nice and clean. So there are various exercises that deal with factorials. And you can see that sometimes you don't have to enter the actual numbers in a calculator, like in the part A of example. You can just see that if you write this 8 factorial on the top as a 8, 7, 6, and so forth, and 5 factorial on the bottom, then the common part will be canceled, right? And all you left with is just a product of 8, 7, and 6, and this is 336. So analogously, you could probably deal with a part C and get the answer, which is 500. Why is that? Because if you put 500 times 499, 498, 497, 496. I say, Alex, maybe enough. Maybe just put dot, 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 because it's just gonna take a while. Yes, that's what I plan. And if you put denominator again, 499, dot, 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 all the way to 1, then you can see that these will cancel. And the answer will be just 500 that we could right away calculate. Let's see if our calculator be able to take this. 500 factorial. Let me try. 500 factorial. If I divide this by, go back to division, by 400 factorial. Calculator cannot do it. See, you are smarter than the calculator. Here's the example. You just cannot do this, right? Calculator cannot do this. Divide for 499, you cannot do it. But you can, because it's 500. See, we can do things that calculator cannot handle. How would you like this example? So that's something that says what artificial intelligence is, right? It's not really intelligence. It's something that people put in it because it cannot think by itself. You're the one who can think, but not the calculator. Calculator just does it. 500, 499, 498, 499, and then gets stuck. And that's it. And cannot notice that all you have to do is just cancel these things. Interesting. Of course, I know that you can say artificial intelligent people program it. Yes, if somebody program it, so if somebody already had enough brain to program it, well, that's it. But by itself, it cannot produce anything new. You can, but the computer cannot, unless you programmed it. That's worth to think about. Well, anyways, so factorials are interesting things, and that's what they actually work out here. So another part of the story deals with so-called permutations. What does that mean? Permutations. I think I should probably get some nicer little example to show you this. And how about actually example 4? I think that'd be an interesting example. That says you and 19 of your friends, so exercise example 4, talks about 20 people. Let me say 19, Alex. Well, it's also includes you and 19, so that's total of 20. So what they do is they try to select 3 officers out of this group of 20 people. So there be a CEO, operating manager, and treasurer. So there are 3 positions. So the question is, how many ways can you do this selection? The CEO, then probably COO, whatever, right? The chief operational manager and treasurer. Well, for the first position, there are 20 candidates to consider, 20 people. Now, somebody can say, let us select Alex, and for the treasurer, and for the operational officer, and for the executive. Well, they want to select different people. And that's the main idea, because they say here they select 3 people, not 1 person to fill all the 3 positions. So that's why once you selected the CEO, for example, then only 19 choices left for the next. And then after you selected the next one, only 18 will be left for the third. And it turns out that there is a formula called permutations for this. So people say you can take permutations from 20, choose 3. And we could just put this in a calculator and get the result. Look at this. If I take this function, notice where the factorial is in this lowest row, I have NPR, that's called number of permutations. So when I choose out of 20, put comma 3, so that's how we use this formula. I'm gonna get something like 6840, 6,840. That's a lot of possibilities, right? And Alex, we're just selecting 3 people. What 6,000? What are you talking about? Well, multiply these numbers. Multiply your 20 by 19 and by 18. And it will be that 6,840. So it turns out the way to do this using a formula with so-called permutations is faster. All you need to realize is what type of selection you're making. So you're selecting out of 20 people, 3. And order is important. Order is important because it makes difference if you be CEO or if you be COO. So that's different position that you have. Order is important. That's the key here. Because if you didn't care what order you assign those positions to, it will be different. But they kind of arrange those 3 selected people and say, you take this position and you take that position. Because if you switch these 2 people around, well, they will take different positions. So that'd be different assignments. So that's not the same. So that's the key idea of the so-called permutation. So order matters. So let's try to do some exercises. I think now it's a good idea to actually practice a little bit. So I'm going to be looking at the exercises here. And I need to get some cleaning done a little bit here. So, for example, exercise number 4. It says, in how many ways can police department arrange 8 suspects in a police lineup? Well, if you start to think about police lineup with 8 positions, then the first position, you can put anyone from these 8 suspects. On the second position, there will be only 7 left. Then we have 6, there we have 8 and 6, 5, 4, 3, 2. And the last position, you don't have a choice, you just put the last one. So there'll be only one choice, just put that person in the last position. So when you do this selection, and for first, and for second, and, we already know that and stands for times. So it's actually going to be 8 factorial. And I can actually use a calculator. Why not? I can put this 8 factorial in my calculator. So let me do this 8, and then I put factorial. And there I have 40,320 possibilities. So police department will have work to do, right? To select this, to arrange those 8 people. Well, I can say, Alex, don't you just take out of 8 suspects 8 selections. So you choose all of them, not 3 like before, but all 8. And you start arranging them so you care about order. So you can also say those are permutations. Please notice the process that we're doing here is we take so many people, we choose all of them. Well, we can choose just one, we can choose 2, we can choose all of them. Why not? And then we arrange them in a position so order is important. So we do have permutations here. So we can actually treat this as if those be permutations. So let me check out if we get the same answer. So we put permutations. You see that factorial permutation, the same last row, put 8, comma 8. You say that's just amazing. That's the same thing. Of course it is the same thing. So if you choose all people from this group, it's always going to end up being factorial. If you choose a little less, please notice that in the previous exercise, I had selected not all 20, but just 3. So I started 20, 19, 18. If I kept going down 17, 16, I would get that factorial at the end of the day. But once I cut this process, I stopped after I selected the third. Well, that happened to be permutations. So factorial is actually very, very close to permutations because the process is pretty much the same. And that's what I want you to observe today. I think that's a very the key observation that we actually making to get better understanding of what is going on. So let's try to do one more exercise. Let's say exercise number like 12 on the next page. So let me clear this a little bit. So today I want to start with this section. I just want to look at the first column of these exercises. I don't think I want to hurry with this because this section has its own specific. So you can look at problems up to number 24. And next time we'll pick up at that place and we'll continue, of course. So I wanted to do problem number 12 here. So I'd like to look at the camp that has counselor and 6 campers that to be seated along the picnic bench. So it's actually 7, right? 7 people. The counselor is 1 person and 6 more campers. So how many selections should this be done? Actually, it's going to be a little bit different. I think we should be a little bit more careful. So they say counselor must be seated in the middle and a camper who has a tendency to engage in food fights must sit to the counselor immediate left. So looks like those campers, they get serious. Whenever they go for lunch, there is a food fight. How about that? Well, that's just very much fun in that camp, right? Anytime they eat, they start food fight. They eat again, food fight. So the counselor said, enough, I sit here in the middle. So I stop you because if I sit all the way at the end, I'll have more difficulty to stop. And the camper, the troublemaker, sits on the left. So we'll say troublemaker, put next to the camper, to the counselor, so that troublemaker sits carefully. Well, I guess being watched. So looks like only 5 positions left here because those 2 are already taken. So we don't really put anyone on these 2 positions because the counselor and the troublemaker next to just sit in this 2 positions. So we just left with 5, right? So how many ways I can arrange remaining food fighters? Well, from 5, I choose all 5. So either you like permutations from 5 to choose all 5, or you want to go with 5 factorial. It is up to you. Interesting, right? So the question is, what is the answer? Well, how about if that be a quiz for you? Quiz for today, what is 5 factorial? So please give me the answer in a Zoom chat, and that'd be our today's little question. I stop recording.